Hello friends, hello students, how are you doing today? Welcome to eSkill Point. Today we are going to talk about probability. Now the word probability is deduced from the word probable. Now in mathematics we call it probability, which means chance. But before we get into the mathematics of probability, you must have heard some words that actually are similar to its meaning. Let's understand this first and you would know exactly how we move through the concept. Yes, you have certainly heard that it rains in the month of June, July. I'm just joking here. I want to bring to your attention some words. Certainly, where you are certain, but again, you cannot give a value to this word certain. Most likely, most likely the COVID situation should get over by March 2021. Most likely. But do you think there is a proof to it? No. Absolutely. You're absolutely sure. That means there is some kind of a data which you have which makes you say this word absolutely. 100%. But let me tell you, all of us use these words only as an assuring, as a strong statement. 100% India is going to win the World Cup. But again, there is no proof to it because we leave things to chance. Probably I should be traveling to Singapore in the month of December. Again, the word probably is that there is a likelihood, there is a chance, there is a possibility. Now, when I use these words, there is no certainty to its 100% execution, and I am not certain that there is going to be an event. Maybe chance. By chance, if I come tomorrow, I would like to have a cup of coffee. Impossible. Oh, Napoleon said impossible is a word in the dictionary of fools, means there are certain things which are possible. Oh, it was impossible for Bill Gates to become a millionaire because he was a school dropout? No, again. So the word impossible may also not have 100% surety of not happening. 50-50. Oh, that's quite possible when you are talking about two teams, one of them is going to win. So the 50-50 is correct. But at the same time, it doesn't assure you of your side. Which side are you on? It's 50-50. In the World Cup India Pakistan match, what are the chances of India winning? 50-50. You're still not sure whether India would win. So, my dear friends, are you getting what I'm getting at? Are you understanding what I'm trying to tell you? Likely, there is a likelihood of rains to continue till January because of the weather conditions. Okay, we don't know. Then you may be having some more examples that you can talk about which spoke about an uncertainty, something that doesn't have a value, something that doesn't have a 100% accuracy, or something that may not become an event. So, my dear friends, we are going to talk about probability, but I'm sure that with these words, you would have understood what I'm hinting at. Let's understand what is a phenomena. A phenomena is actually an event that happens. A phenomena is like an event that happened. For example, it rained heavily on July 26th in the year 2010 and Mumbai was flooded. I mean, I'm just giving a random date. The date is fine, the year may not be. That is a phenomena. But do you think that phenomena happens every July 26th? No. So a phenomena is an event, a mathematical event that happens. Okay? It could be a tossing of a coin. It's a phenomena. Now, what happens is when you do a random experiment. What is a random experiment? Well, a random experiment is something that in which all the possible results are known, but none of them can be predicted with certainty. Can I tell you something? In this case, let me give a tossing of a coin in the random experiment. Now, what are the possible results? When you toss a coin, you either get a heads or a tail. correct? But can you predict it? No, you cannot predict the same with certainty, because there is an equal possibility of each of the result. It could be heads, it could be tails. Outcome is basically the result of a random experiment. Outcome is a result of the experiment, the random experiment. Like I said, it could be a heads or it could be a tail. Now that's an outcome. Having said that, let's move ahead. Okay, you have understood what is a phenomena, what is an event, what is an outcome. I am going to talk about something called as sample space. What is a sample space? Now, when I toss a coin in the air, it is an event. Now, the result of the event are the possibilities which I call as a sample space. What happens when you toss a coin? You either get a heads or a tail, isn't it? So, what is my sample space here? My sample space is either a heads or a tail, which means there are only two possible outcomes when one coin is tossed. Can you think of something else? Well, there are certain movies that may show you that this coin is standing, which doesn't actually happen. It's for entertainment. Let's not get to that. So the sample space, which is represented by the letter S, is the notation given for probability, for heads and tails, which is the two outcomes when a coin is tossed, which is an event. So pay attention. In the probability, we are talking about an event. You need to understand what happened. The event is what happened. In this case, a coin is tossed. The result is unpredictable. A phenomena has happened. Result, we don't know, but the result will happen. Sample is one of the outcomes. It is the total set of outcomes. When a coin is tossed, I may get a tail, I may get a head. So my sample space is 2. Do you understand? But only one would happen, that is the outcome. So the sample space is the total sum of outcomes that can happen when an event happens. Are you clear on this? And we know that there is no third possibility. So we can either have a head or a tail. I don't need to repeat myself. I've been very clear in what I'm speaking. Let us move ahead. Here I'm talking about two coins that are being tossed in the air, and very carefully I am now using H as heads and T as tail, keeping the first coin as head. I'm keeping it constant. The first coin is head, the second becomes tail. One of the outcomes. The first coin is still heads and the second coin is heads. Well, this is the second outcome, a second possibility. Now we change the first coin because we have given it the chance of being a head. Okay, in both the situations where the second coin is head or tail. Now I change the second coin to tail. Again, the second coin be tail. So both of them tails is a third possibility. Keeping the same first coin as tails and the second coin as H, we have the fourth possibility. So the sample space means the event of two coins getting into the air and landing. We could have 4 possible outcomes. The sample space, number of sample space ns is equal to 4, as I have mentioned here. Can you think of anything else? I bet you can't. I'm becoming a little bit more bolder and trying to teach to you what happens when 3 coins are tossed in the air. The sample space now becomes 8. You figure it out how we reach this. HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. Oh, is that easy? No, it's not. No, it's not. What have I done? Think. Look at these 8 possibilities. What have I done? I am keeping the first 2 coins constant here. Think about it. Now the third coin can either become an H or a T. We have, you know that with every two possible outcomes, there is nothing more left. So what happens? I have changed the second coin now, keeping the first coin constant. I am changing the second coin to T because I already had the second coin as H. So again, I get an H or a T. You get my point? Okay, now the second coin is changed. Now we already had the first coin as H. I'm going to change the first coin as T. Again with the same situation, T, H, H. Again, I'm keeping the second coin constant and the third one is changing. See, the third one is H and third is T. Now please pay attention. You can arrive at these three outcomes very easily. It is not a rocket science. Can you think of a ninth outcome? No, you cannot. So when you toss the three coins in the air, the total sample space NS is equal to 8. I hope I have been very clear in making you understand how we arrive at this sample space. Right, let's move ahead. So let's understand now the probability. We got some things called as event. Wow, we got an event and we have the total space. In a single coin getting tossed, you get a head or a tail. So the probability formula that we use is the event upon total sample space. So the probability is half because either a head or a tail is one of the event and the sample space is 2. All right. Now, if you see the cricket match, when a coin is tossed, either of the captains are given an equal chance. Now pay attention, an equal chance. Hope you can read this. Why is it an equal chance? Because half plus half. Both the teams have got an equal chance, half and half, which is 1. That means the event is 1, but both of them got an equal chance of either choosing a head or a tail. All right. Now it's an equal chance. You toss the coin in the air. It is called a fair coin or a fair dice. We'll talk about the die later on. Dice is in your Ludo and the games. We play a game of dice which has got 6 sides. It's called a fair dice. Fair dice means in all probability the dice have got equal size and shapes, and the 6 digits which are etched on that, any of the 6 sides can come on top. So there is no play. All the 4 sides of the cube are evenly balanced, so that there is no ambiguity about getting 6 or getting 5 because of a certain play in the die. No, we are not talking that. So we call it as a fair die. Okay. Here, coming back to the coin, in 3 coins that we were talking about, we had 8 possibilities, which means the sample space was 8. Now to get a head or a tail, the probability is 1 upon 8, isn't it? Now, did you understand how we got 1 upon 8? Because head or a tail is one of the events and the total outcome is 8. Now, if you say that to get more than 2 heads, the probability is 4 upon 8, which is half. Now, if you were to go back to the video, we have this H, 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 T. Now, you see this? Here is the situation, 2 heads. When are the 2 heads coming? In the first case, it could be in the first coin getting heads and the second coin getting edge, and later on the second coin and the third coin getting edge, isn't it? Now that makes it 4. So when you have more than 2 heads, the probability is 4 upon 8. You can go and check the sequence, the sample space that I've written. You will see that wherever there are more than 2 heads, it is 4 times. All right. So more than 2, 4. And similarly for the tails. Okay, so you have 4 occasions where we are getting more than 2 heads and the total space is 8, which is 1 upon 2 half. So that means it is a fair chance. Let's discuss a die. A die, everybody knows what's a die. Okay, I already spoke about it a while back. It has got 6 sides, so the sample space is 6. What is the probability of getting more than 3? Naturally, what is probably more than 3 is 4, 5, 6. So again, it is 3. So there are 3 occasions where when you roll a die and the total number of sample space is 6, so you get 1 upon 2, which is half. Similarly, I can ask the same question. What is the probability of getting less than 4? Less than 4 is 1, 2, and 3. It again is half. I hope you have understood the formula. Probability equals to event upon total sample space is what you need to remember. Okay, let's move ahead. Earlier we had 2 coins being tossed. Now we have 2 die being tossed. Now this is going to be a little tricky. You know why? Because in the coin we only had heads and tails. Now let's look at this. We have the first die as 1, the second die as 1, the first as 1. I'm keeping it constant till till the second die is become 6. Now the first die is again 2. I mean, we have the second digit showing up. The second die is showing 1, and we go on till we get as 6, 6. That means both the die are appearing as 6 and 6. What do we get here? We get the sample space as 36. Now this is fun. Let's look at E is an event where the sum of the digits is a prime number. Now you have to write this individually. What is the sum being a prime number? Do you know what's a prime number? A number that can only be divided by itself. Okay, and it cannot be further subdivided. All right, and which results into a clean natural number. Here we are. NE, which is an event, is 15. Now you'll have to write down where the sum of the digits is a prime number. What is the maximum that you can get in a situation like this? Can you tell me? Can you tell me? Come on, think. We have a die, okay, which has got 2 dots. Okay, we have a die that has got 1 dot. So the sum is 3, which is a prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number. What else can we get? Now in this situation, you can also have different variants. Now how can we get 7? We have 4 dots and 3 dots. How can we get 5? We have 3 dots and 2 dots. We have 2 dots and 3 dots. How we can get 11? We can get 1, 2, 3, 4, 5 dots, and we have 6 dots. Okay, so you need to write this down individually. For further explanation, I'm gonna add a video where I will show you how to arrive at this, where the sum of the digits becomes a prime number. Okay, what happens is, so the number of events in this situation are 15, and we know the sample space is 36. So 5 upon 12 is what we get as the answer. I have to teach you something different here. What happens when the 2 die are tossed? We got the situation when the sample 6 is 36. Right? F is an event where the sum of the 2 digits is a multiple of 5. Now this is so easy. Sum of 2 digits is a multiple of 5. Now I told you very easily how we can get this. So you have 36 as the sample space. Let's look at some events here. The first die is 1 and the second is 4. Total them up, 5. The first die is 2 and the second die is 3. What is the total? 5. The first die is 3 and the second is 2. Third, uh, third event outcome, and in this case the 4 and 1, 4 and 6, 6 and 4, 5 and 5. Let's total this up. 1 2 3 4 5 6 7. So here we have 7 upon 36 as the probability where the sum of two digits is a multiple of 5. Now my dear friends, I'm sure you would have understood this, and I can tell you that having said that, you can now go back to the prime number problem and solve it yourself. Okay, let's look at this. What are we looking here at? We are looking at two dice, okay, being tossed. We know the sample space is 36. Let's look at G as an event. Event where the sum of the two digits on the upper face is 25. Well, the sum of two digits as 25, I can never think that is going to be possible. Do you know why? What is the maximum digits you get in one dice? 6. In two die, it is 12. How on earth can we get 25? So we call the sample space as an empty set. Now pay attention, friends. Can I write 0 here? Think. No. 0 has got, though it has got no value, it is an empty set. We cannot write 0. Okay, it's called an empty set. So we leave it as at that. We leave the brace brackets without anything there, and it is called an empty set. Again, these are some of the situations which may come to you as a problem, and you need to answer it in that right way. Very interesting, problem that I can teach you here. Again, using two die. Event where the first number is less than the first number is less than the number of the second die. Now, how can that happen? Let's look at the first number as 1 2, yes, less, 1 3 1 4 1 5 1 6. The other situation is 2 3 2 4 2 5 2 6. Correct? 3 4 3 5 3 6 4 5 4 6 5 5 6. Now what are the situations? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Again we have the answer as 5 upon 12, which means it has been reduced from 15 upon 36. 15 has been the number of events, the outcomes which actually fit this condition where the first number is less than the second number of the die, okay, which are number 15. Total sample space is 36. Interesting. Now you would start getting more excited as you understand what we are doing. So my dear friends, I want you to go through the video should you have not understood or should you have any queries. Feel free to comment, and I want you to subscribe to my channel. Have a lot of fun. Probability is fun. You get a lot of marks, and trust me, it is one of the easiest subjects that you can actually master and you can actually score. Thank you for subscribing. Thank you for being here today and listening. You take care. Bye bye.